Charles Messier got inspired to become an astronomer at a young age. And his work led to him accidentally creating one of the most famous catalogues of deep sky objects ever made. Charles Messier was born on June 26, 1730 in France. He had a rather rough childhood to start with. 6 out of his 11 siblings died at a young age, and his dad died in 1741 when Charles was only 11. But his interest in astronomy was piqued 2 years later when he was 14 in 1744. Some of you may know that this is the year of the Great Comet, which was a very large comet that passed close by Earth. Now, this thing was visible for months, and visible to the naked eye even. And when it peaked, even during the day, it was visible to the naked eye. It's difficult to judge exactly how bright it was since, well, magnitude measurements was not really a thing, so we have to rely on what we know from historical record at the time. But it seems like it peaked at an apparent magnitude of around -7. And to put that in perspective, that's about a half to a quarter moon. As this thing moved in closer to the sun, it displayed not just 1 or 2 tails as we're used to seeing from comets, but all the way up to 6 tails that were visible at the same time. And when I first read that, I was really puzzled, like how can that happen? I mean, I can understand 1, I can understand 2, but how do we explain 6? Well, it turned out it wasn't necessarily 6 tails in the sense that we understand it today, or we would describe a tail today. But what astronomers think happened was because the comet had a very asymmetrical shape, and it was apparently rotating around its own axis relatively quickly. That meant that as these different regions of the comet was facing the sun, the intensity that it would eject material was also changing and oscillating with the rotation of the comet. And because of that, the tail, and as it was then moving and that this tail was kind of fanning out, because it was kind of the tail was active and then not so active, then active again and not so active, it kind of looked like it had multiple tails at the same time, even though they were probably technically just the same tails, but they were just split up into multiple sections, making it look like it had up to 6 active tails at the same time. This inspired him so much that in 1751, Messier entered into an employment with Joseph Nicolas Delisle, who was an astronomer in the French Navy. Joseph told him to keep detailed record of all his observations. And Charles was still so interested in mainly comets that he's devoted his entire career to locating new comets. However, he quickly encountered a problem, and that was that it was kind of difficult to distinguish between galaxies, nebulae, and comets, because through the telescope we had at the time, they all kind of looked like fuzzy objects, right? They were just not point stars, at least. And that meant that sometimes it was easy to mistake a galaxy for a comet, or the other way around. So Messier, he did what any good scientist would do, and he began to keep detailed record of all these super annoying static comet-like objects, as he called them. So basically, it looks like a comet, but it doesn't move, aka not a comet. And he kept detailed records of all of these, so that when he saw them, he would know that this wasn't a comet, this was something else. He maybe didn't know at the time exactly what it was, but at least he knew it was not a comet. One thing that I found extremely interesting about all of this, really fascinating, is that all these galaxies, all these nebulas and comets that Messier was looking at and cataloging, well, they were all done with a 100 millimeter 4-inch refractor. And it was done in downtown Paris, and I know that in like 1750 or whatever, like light pollution in downtown Paris was probably noticeably less than what it is today. But still, I think it's quite fascinating, especially with all this like hype there is for getting better and better telescopes today, that what they had back then was, well, what we would consider a low-end telescope today. And because all his observations were done from Paris, that explains why all objects in the Messier catalogue are visible from the Northern Hemisphere, because they will all be visible at some point during the year from Paris. Otherwise, he would never have been able to see them. And again, it also explains why they are not sorted in any way at all, because he didn't really care what they were. He didn't care if it was a nebula, it was a galaxy. For him, it was just not a comet object. So he just wrote them down, one or the other, said, you're not a comet, you're not a comet, you're not a comet. And that explains why there's no structure to them. It was just the order that he happened to write them down as he was making his observations. And again, because small telescope, that also means that all the objects in the catalogue are bright objects, right? Because all the small, faint, small galaxies couldn't see them. And that meant that accidentally, what Messier created was probably the best catalogue of objects that's easy to photograph in the Northern Hemisphere by complete accident. And this is why that if you see an object that is listed in the Messier catalog, so if it has an M number, then you know that it's an object that's going to be visible in the Northern Hemisphere at some point during the year, and that it is a relatively easy to photograph object, and it's going to be relatively bright for Messier to be able to see them. Guys were taking pictures during the night, during the day, and Pickings had a team of women called the Howard Computers. They repurposed the third stage of a Saturn V rocket. Now that they didn't need to go all the way to the moon, they didn't actually need the third stage.